Okay, hello everyone. My name is Oskars, and today I'm gonna talk about React Native and ClojureScript. Will it blend? Well, let's find that out. Something's not working. Okay, so a small intro about me. I'm a mobile developer. I've been working with mobile applications since 2012, and mostly I've done native apps development on iOS. I have done some couple of developments using also cross-platform tools like PhoneGap and Ionic, but those frameworks didn't leave me impressed, and I was true believer of writing pure native code. Currently I'm working at FullContact as a mobile apps developer, and been working here since last year from July. Small words about FullContact. We are a Denver-based company with offices in Riga, Kochi, and Dallas, and we are trying to solve world's contact problem, or as we like to say, we just like to be awesome with people. So React Native and ClojureScript blended together in a clearly non-branded blender. So how many of you are familiar with React Native and ClojureScript? Is anyone using any of this?
This combination, no?
This combination, no, it's not typical one, but okay. So why React Native? And what is React Native? Well, React Native is a JavaScript framework that you can write and render native mobile components and UI elements, and it's going to be displayed accordingly on which platform you are running this application. On iOS you would see iOS elements, and Android you would see native Android elements. And React Native is based on the Facebook's JavaScript framework, React, which is used in the mobile development for web pages. And and the reason why we chose React Native for our mobile applications, because React proved itself in FullContact's web application. Last year we launched a web application that was written with React and ClojureScript, and what we wanted to do, we wanted to unify our code bases and conventions even more. So we wanted to apply conventions and patterns that we learned from the web application. And more about React Native. Who else is using React Native? Of course, Facebook is eating their own dog food. They have built a Facebook group application. They use it in Ads Manager. There are a couple parts written in Instagram that uses React Native. And another one I would like to mention is Airbnb. They are using React Native in some of the parts in the application, and they are also quite active with developing frameworks and libraries. For example, they're trying to solve a navigation problem when using React Native, and another interesting thing is they have built a library that transfers Adobe After Effects animations into usable animations that you can just use in your React Native apps. Okay, and why ClojureScript? Okay, the first reason is quite obvious. You're not going to write JavaScript if you write ClojureScript, and that's a win because we don't like it. But the real reason is
the good part.
The good part. But the real reason is because we are trying to reuse the patterns from our web application. And okay, maybe some small introduction to the Clojure. Clojure is a programming language with emphasis on functional programming. It runs on the JVM, and ClojureScript accordingly compiles to the JavaScript. So in a way you get the power with Clojure and also mobility to run it in web browsers and mobile devices. So yeah, for us it made sense to use ClojureScript instead of JavaScript because we have this already patterns and logic written in ClojureScript. So we wanted to enable more code reuse. And the story so far, why we chose React Native and why we wanted to do cross-platform. So everyone wants to write a code that is reusable on multiple platforms. We quite often felt that we were doing the same thing twice. At first we would ship something on the iOS application, and sometime later we're gonna need the same thing on Android. So we felt that we needed to unify some of this stuff, and even more when our UI and UX experiences are getting even more similar on Android and iOS. We wanted to try out implementing with onboarding experience in our app. At first we wrote our onboarding experience purely native on the iOS application. We shipped it at the start of the year, and so upcoming stuff in the roadmap was to do the same thing for the Android. And that's when we decided that we need to write this again in a cross-platform way, so we could reuse it on the iOS again and on the Android, and that means that we only need to maintain one code base for this specific workflow. So yeah, we decided to go with the React Native, use ClojureScript. Of course, it sounds like a risky move because no one in our mobile apps team didn't have an extensive knowledge of React Native or ClojureScript. And that's where our head of engineering, Kasper, stepped in, and he basically applied his knowledge from the web application, and we implemented a pretty similar stack in our mobile apps that is really, we are using the same patterns. And yeah, thanks to his knowledge, we were able to set up our stack for cross-platform development on mobile. And it's kind of amazing how well these patterns works in our mobile apps. And of course, there are some problems also introduced, because we had running applications, purely native applications on Android and iOS, and we didn't have any code share previously. So all data resides in the native apps, and in that case we need to write bridges that gaps this space between React Native and native application code. And yeah, so currently more about this onboarding experience. We finished this working prototype with all the learning curve in 2 weeks. And after 2 weeks, it was almost done. There were still some couple things that needed to be polished, but it started out as a prototype, and now it's actually shipped in production, and we have one module running in React Native. And after this onboarding experience, we wanted to do something more complex, because onboarding mostly consists of static views that should have been displayed in defined order. And we continued with building different prototypes that would be more advanced. For example, a list view which is responsive to changing data, and it should so we set out to build an advanced list view, because list views are like the most common basic component that our apps are built from. And our acceptance criteria was there is no performance degradation, it's dynamic, it reacts well to the layout changes, we can insert new items, sections, remove them, and it should also look nice. The animations on insert or delete, we should be able to reorder items flawlessly by drag and drop operation, and also it should receive data from the native side, modify it, and pass it back to the native side. Okay, so that was the story, why we did this all, and let's now talk about stack, how we put this into our existing native applications. The first of all, there's a framework called Reagent. Basically, Reagent provides a way to write React Native components using ClojureScript. And with the Reagent, the React component is a function that defines how UI should look. You can combine and nest multiple different components to create even more complex views, and it also enables you to write reusable components across the app. And another thing that components do, they also are responsible for listening to incoming data changes. Usually a component consists of subscribing to some data and implementing render function where you redraw, re-render UI accordingly when the data in the state has changed. Next thing in our stack is reframe. Reframe is a pattern for writing ClojureScript with Reagent. At a high level, reframe works like a cycle. Basically, you've got view components that are rendered on the screen, and you can interact with those components. And as you interact with view components, you dispatch events that are then handled by handlers. No pun intended. And the handler's work is to usually modify data and whatever what might need to do. And when the data is changed by the handlers, this usually gets pushed back to the view components. The view components get notified that state has changed, and you need to re-render yourself again with the latest and greatest data. And it works in a cycle. It's just like an infinite loop. So to recap, you dispatch an event from UI component, event handler receives it, something happens or changes in the application state, and UI component has subscribed to the state changes, and it re-renders itself. And you don't need to call update explicitly on the components. It's all handled by this reframe pattern. And one more thing about reframe, that all application state on the React side lives in a single in-memory database. We can call it application state. And in ClojureScript, this application state is a simple data structure, a map, and you are responsible about defining the structure of this map. You can put everything you need in there. And some paths from this application state are referenced in the UI components, and that's how UI components only listens to changes in application states that they are responsible for. So it doesn't receive updates from another state changes, it just listens to what it needs for rendering. Figwheel. Figwheel is a plugin that is used extensively in ClojureScript projects. What Figwheel gives you hot code reloading and live coding options. So you can change the code on the fly, and if it would reflect on the simulator instantly. Similarly, like all this showed in his views presentation. ReneToe is a utility tool that basically simplifies this process of setting up your project for using Reagent, reframe, and basically it just provides you with utility commands that you can run and set up your project to use all of these frameworks. And this is also used if you want to add some external React Native dependencies to your project. About layouting, this is also a pretty important part. React Native uses Flexbox, which is pretty similar how Flexbox works in CSS. The Flexbox layout aims to provide a more efficient way to lay out UI elements, align them, distribute space between them, and resize accordingly depending on the content size and how much space it needs, or shrink or grow. That depends on how you define what the element should do. And flex container could lay out elements in columns or rows, and when you combine those flex containers, you can create pretty complicated layouts that would be pretty hard to implement using native code. For example, we have this collection view that automatically reacts to the state changes, and then when you delete something, the flexbox will make sure it aligns elements like it should do, and you don't need to specify each position of the element or where it should be placed, and so on. Okay, and talking about native bridges. So we have existing native applications, and React Native without any data would be pretty useless. So we need to write bridges, a gap between native module and React Native. So in our apps, each platform, iOS and Android, implements a model bridge class, which can listen to events from React Native and also dispatch events to React Native side. Also, those events could include data that it's needed for React Native and receive data, and it goes back and forth. It's like a communication between native and React Native. And the presentation is handled by UI view controllers on iOS and activity subclasses on Android. And currently we are responsible for initiating these view controllers and activities. If we want to start React Native workflow, we would initialize subclass of these controllers or activities and initialize them with React root views. We would specify which React component we wanted to see in those root views. So much stuff and how it all comes together. So we talked about stack, about reframe, pattern, ClojureScript, native bridges. Now we should go through it all and see how it works together. So the usual workflow. You start fig wheel sessions for iOS and Android. That will give you a code reloading on the fly. It also will start REPL sessions, which is useful for debugging, but more about that a bit later. Then we run React Native packager that bundles all the files and assets that are needed for running our React Native applications, and then we launch our native apps from Xcode and Android Studio accordingly. And when all of this is done, we are ready to develop and debug React Native code on the fly. We're gonna take a look at how this custom collection view is implemented. And basically it just displays some items that are received from native side, and on the click it deletes item from the collection. So it all starts from the native code. We decide to present UI that's built with React Native. Our apps creates controllers or activities, and we say that we want a root view, this collection view. So we tell control activity instances, we use this React component, and now it's our responsibility to present these controllers or activities on our navigation stack. From this point, when controllers are presented, it's now React Native's role to step in. So at the beginning, when this component is rendered, we should ask for data from the native side because it lies in there. We have defined two handlers here. One of them is load items, and when this handler is dispatched, we would ask for the native bridge to give us items, and we have defined the callback handler load items response. And in that we would that response handler would be called from the native side when the data is prepared. For example, we have items, objects in native side. We would transform them to simple maps and dictionaries because ClojureScript doesn't have any classes and all data is stored in vectors, lists, and maps. Here we can see our first component, collection view. In the app, we have referenced data in our single application state. We have stored items in data and items. It should return a list of items. And our collection view references this reaction. It works like a subscription. When items will change in the single app state, it will automatically trigger this inner function which is responsible for rendering our view. Yeah, by the way, this is ClojureScript. I hope it doesn't look too scary, but it makes sense in a way. Yeah, I think also the designers can just step in and change UI because styling looks like CSS and it's pretty easy. Okay, so this is our collection view component, and inside of the function we just go over the items we have received from the application state and display a cell for each of those. And this is a function that returns cell which contains a touchable highlight, which is a button, and a text with an item. So we pass in text we want to display, we pass in index, and this index is used for another handler. On button press, we're going to dispatch another handler delete item. And we pass the index, that means we want to delete this particular cell. And here we have a final handler delete item, which creates new application state. So yeah, in Clojure everything is immutable. We're dealing with pure functions mostly, and we do not mutate existing data structures, but we do some operations with them and we return new values. And in this case we delete an item at the index and we return new database state. And when this is done, our UI component would be notified about these changes and it would re-render itself automatically. And when all of this is done, we can call handler dispatch event save items, which would then call native code, and we would pass a modified list of items. For example, we deleted some of those items and now we just give this list back to our native side, and native bridge would then decide what to do with this data. Should it persist or send it to the backend, whatever, depends on the use case. So what about debugging? Debugging works actually pretty well. Figwheel gives us REPL, hot code reloading, which provides us quick iteration while developing. And yeah, that means that we also do not need to recompile our native applications each time when we make some change in the React Native side. A good thing about the REPL is that you don't need finished UI to test your business logic that's written in React Native. So yeah. And something more interesting is Chrome debug tools. You can enable the developers menu on your native applications and you have option to debug JS remotely. And what it does, it launches a local host on the Chrome, and you can actually put breakpoints in the ClojureScript. I know, crazy. From there you can put breakpoints and you can inspect what's inside of the past parameters, what are the values. But much simpler approach is just sometimes to log everything on the screen and see it on the fly. For example, I'm logging when item is deleted at some of the indexes, and this yellow banner comes bundled together with React Native. And good thing about this banner, it's gonna be disabled in the production build. So if you forget to remove your log statements, it won't mess up your production application. And another thing, you can also test on your device. So you just need to be on the same Wi-Fi network as your device and the device and laptop, because they are running on the server, this code. And so what's cool about this all? Aside from obvious advantage having shared code between multiple platforms, I also want to highlight another things that we learned from our experience with integrating this. Reactive approach and functional approach, it works really well with the UI and state changes. You don't explicitly call update methods on your components, as it just gets rendered automatically. And that's Clojure is a functional programming that returns pure functions. It makes it easy to write unit tests for them. So immutable data, pure functions, it's amazing. And the Flexbox, it actually works pretty well when you get a hang of it. At first it was a bit confusing and being used to auto layout in the iOS. It took some time to grasp all the concepts, but when you understand how it works, it's pretty sweet, because you could write this complex collection view layout in less than 20 ClojureScript lines. But not everything is sunshine and rainbows all of the time. So on typical workday, at the same time, I would have open 4 terminal windows for packager, for Figwheel sessions, and for whatever else. And I would have open Xcode, Android Studio, because I need to launch native applications. I would have IntelliJ IDEA with cursive plugin for writing ClojureScript. And I would have iOS simulator and Android emulator. And at times it feels like my laptop is preparing for a liftoff, and it seems that only solution is to download more RAM. And yeah, but all in all, it's just getting used to the new workflow. It's all about the learning curve and trying to grasp all these new concepts all together. And if you're used to pure native development with MVC pattern, it might seem a bit crazy at times. But yeah, just step outside of the comfort zone and you should be good. More practical downside of integrating React Native is the increase of the size on IPA and APK files. If I remember correctly, the application that was bundled with React Native for Android grew in size about 6 megabytes or so. About future, we're moving forward. We are planning to do more awesome stuff with React Native. We are already working on different prototypes that that's going to be like a base for the future stuff, the new designs, and yeah, we hope to do much more with it, not just this simple onboarding flow. And another thing that we want to do is write more business logic in React Native, because at times it feels like we're doing something backwards. We're writing a shared UI interface, but we're still making calls to the native application side for business logic, for data, for anything else that's not UI related. So if we bring more business logic into our React Native side, okay, that simplifies a lot of things. We don't need to bridge that often from one side to another. We can make requests, build a persistence layer in a React Native side, and yeah, it's gonna be much more simpler. And the good thing about this React Native and ClojureScript, that we can actually share code between our web application, which would make us truly cross-platform. And we already are using code from web app, for example, for making network requests, and we lifted patterns for building UI components. Well, it's not the same thing as in React and React Native, but the similarities are there. And it means that mobile devs can finally talk to our web developers, and we understand each other now. And if you are interested in more about this, I encourage you to visit those resources. The first site is quite extensive guide how to integrate all of this into your existing applications or start new application, and also encourage you to read about reframe pattern, because I think that's an interesting concept and philosophy. So yeah, thanks for the attention. This was a story how we integrated React Native and in our existing applications, and yeah, thank you. Are there any questions?